You may remember this robot from when it was self-balancing. Now it has a third wheel, and I'm taking it to Maker Faire. Now I'm just cleaning up the absolute mess that I have in the workshop and making sure that everything is ready to go for the next 2 or 3 weeks of work for Maker Faire. The only project that I'm currently worried about finishing and getting ready to, well, not finishing, but getting ready to go for Maker Faire is the robot. It's in 2 weeks. I need to be able to design something just to rig up the electronics and mount them to the robot, which means I have to mount the microcontroller, I have to mount the computer, and I have to mount the motor driver. Okay, so I don't know if you can hear that in the background, but the 3D printer is running. I'm happy because I finished part of the CAD, which is the part that's on there. It's the front, it's got what I'm calling the front latch bar. It slides on top of those 2 bars on the droid in the front, and then it has sockets with holes for screws. All of these components have the same 20 by 10 millimeter socket that will let me put some threaded inserts and then screw the whole thing together. A little bit of a 3D printing update. Almost everything completely fits on the first try. This back latch bar, the holes were slightly too small for the threaded rods. I just drilled them out a little bit, and I'll make some edits in the CAD for the next pieces of these that have to go on. But the front latch bar was absolutely perfect. Also, what was perfect, this piece, the part that runs from front to back, snaps into these sockets like this completely perfectly. It's excellent. I'm going to go over the way that some of these electronics actually work and the kind of connections that I've made and the decisions that I'm going with. So if we take a look here, we've got the battery connector, which takes 20 volts in from the lithium-ion battery. That goes through a 20 amp fuse. The power button lights up when it is active, so when there's power to the system, this lights up red. When it's pressed in and clicked down, the power is off. So basically, if there was an emergency and I need to stop the robot, all I have to do is smack it on the back and it will turn off. Then we have this low voltage cutoff board, which the 20 volts goes in, and then the 20 volts comes out of here, given that this isn't met at the threshold. And then we have this whole mess here. So if I disconnect this, there we go. Disregarding all this, which you already went over, these are just the connections of 20 volts, the buck converter there. So the buck converter takes 20 volts in from the low voltage cutoff board, which is coming from the battery, and sends that as 5 volts into the microcontroller. Now, the microcontroller will be connected over USB, but I'm only using that for serial and not power, because I want the microcontroller to be able to turn on and off the main computer. This connector takes 20 volts and sends it into the motor driver. The motor wires are connected through this connection, and that just sits there like that. So eventually I'm going to rig up all these electronics so that way they're nice and clean inside the robot, and hopefully that's the next step after getting the main computer mount printed. Alright, this is a tethered test of joystick control with the Xbox controller. Okay, so the reason I'm all sweaty and quite exasperated is because about a few hours ago, I was on my way to attach one of the last 3D printed pieces I needed to make the whole system wireless. This attaches the main computer and the battery to the back of the robot, and I accidentally hit the door frame coming into my room, and I dropped the robot. So these two steel bars were attached here on the motor, and they were only held in by these two screws. Unfortunately, because of that, the rest of the robot was rigid. This line here, where you see this epoxy, which I'll talk about in a second, completely sheared off. It just split straight down the middle and basically took this whole motor off of the robot. The good news is that I think I've fixed it, and I'm about 30 minutes away from reassembling it. So I got this steel stick epoxy, so I came up with this idea to put the ties across here, and I only had one piece of aluminum to do that for now, so that's the way it'll be for now, and hopefully I can get this connected back here where it was over on the robot, and yeah, we'll see.
And right under the wire, HB2O makes its debut at Maker Faire Orlando 2022. There's obviously a lot more work to be done. I've got some interesting things planned with this robot in the future, so stay tuned for that. Thank you for watching, and as always, you can see more on hackbatch.com.